Hello, everybody. Hope you can hear me very well. As I said, you told your friends and they are coming. This is good. Tell all your friends. So my name is Stefan Adolf. I'll give a talk about API platform, how we build our IoT smart shelf and their marketplaces in no time. As you notice, this is quite a long title. This is really hard to talk freely, but you can also read it. Now, this is me. You can, I guess my Twitter handle is also written somewhere over there. If you want, you can follow me. I will share the slides. I will share most of the code and lots of nice tweets on this channel. These are my hashtags at the top. And I'm working for a company called Turbine Kreuzberg, which you should remember. We are not a soccer club or something. We are doing B2B commerce. We're doing it on quite a high scale. And we have, well, high-rolling customers. And these are our hashtags. If you want, you can also follow me on GitHub, where you find lots of bad code. But up to our topic. So I don't know if I am allowed to show this slide. So please don't take a picture now. If you know Forrest Gump, he always said he is not a very smart man. But from my point of view, he's much smarter than these people. These are shelves storing things. In this case, on quite a high scale. So I want you to close your eyes and imagine a shelf that tracks its inventory and can place orders automatically. Like imagine a shelf in your kitchen and it completely controls itself. If your peas go out or if you don't have any steaks left or the milk is running out, it automatically orders things. What would you need to build this kind of shelf? First, you need a shelf. Then you might need sensors. This is why this is called the IoT track, you remember? So you will need some little guys who will measure the things that you have put in your shelf. What you also will need is a concept. You will definitely need someone who comes up with the ideas. And you need t-shirts. This is the first thing we did. We printed t-shirts with a name you can already forget again. And these are my colleagues building up all the shelf stuff. That was it. We built a smart shelf. And what I did not mention here is, we need a backend for our shelf. I mean, somewhere we have to put the data somewhere. And this is why I would like to show you the architecture that we invented. So the idea of the smart shelf that we are building at Turbine Kreuzberg is that we have a swarm of devices. And these devices track, or they are supposed to track, the stocks of items. Now, unfortunately, these devices are not very clever because they're so small and they don't have that much computing power or databases. And this is why they are only sending a constant stream of so-called change events to a local message broker. Okay? This broker is gathering all the events and is relaying them towards an event gateway. This one gathers all the events by all the gateway and message brokers. And in the last step, it's pushing all these events to a REST API. And as you might remember, the title is about API platform, so you know where this one comes into play. This REST API translates the so-called sensor changes to inventory changes. Because the sensors only say, well, now we have 1 meter, we have 1 meter 50, we have 40 centimeters. This is everything these little guys can do. But now what we're interested in is how many peas, how many milk, how many, I don't know, eggs do we have left, how many beverages in our case. And this is what we call the inventory change. After that, there's some kind of smart shelf hub, as we call it, like a multi-store. So there are many shelves connected to one hub. And this one takes care of making sense of the actual change. So this one brings in the real product data. It says, okay, if this sensor says it has 50 centimeters, it means that we only got 1 milk left, which is maybe 20% of the total milk stocks that's possible. And afterwards, so this hub also has some kind of order rule set, which says, okay, I mean, I can live without the milk, but please reorder coffee as soon as possible, because I don't like milk anyway. So these order rules take care of creating orders in the end. Said, okay, I think we're now running out of stuff. We should place an order. What then is happening, and this is what we're currently implementing, this shelf or this smart shelf hub is now negotiating with suppliers for customers where to order the milk, because some suppliers may have cheaper milk than others. Hello, welcome. So if we found a good result, we are placing the order automatically. Actually, we are sending an email currently to the supplier and saying, hey, we need 10 more milk. And well, then it's shipped, and then it's stored, or the shipment is placed into our shelf, and then the story begins at 0. And we're measuring new stocks, and well, yeah, we can order new things. This is the whole architecture. Since this is the IoT track, I will not skip this slide because there are maybe some people interested in the IoT backworkings. So we are using the so-called, I will not pronounce it, these laser measurement sensors here, or these ranging sensors. They can measure a distance up to 400 centimeters. This means if you have a shelf and there are slots where you store products, they are measuring the distance from the back of the shelf to the next product that it can see. What they're actually doing is they only can they are measuring an angle, a field of view angle. They only can measure how far they can look to the sides, and we are recomputing this using some Pythagoras and tangents computation, very mathematical, to measure the real distance. I will need to tell you a little bit about the naming in our system so you understand what I will talk about in some seconds. So first of all, we got some users in the system. That's obvious, users which interact with the system. Then we got the shelves as a concept. So there are several shelves which belong to an organization, which is not depicted here. In each of the shelves, there are so-called slots where you store the products. The little green circles are depicting the sensors. Each slot comes with a sensor, which is measuring how much they're stored in one slot. And now the business domain is starting. The product stream can consist of several slots. You can store, let's say, Fritz Cola in 3 slots because you need lots of it. Every product stream is now related to a product, like the Fritz Cola, and several suppliers can supply the product. And now you know all the wordings. In the wild, how does it look like? So first we got these sensors. They look like this. I did not bring one because the last time I brought one, it was broken after 3 minutes. But I trust you, Sorry. Then we have this IoT, so it's actually only a Wi-Fi router with OpenWRT. We call it the IoT gateway installed on it, which is rather simple. It's just an endpoint for MQTT. So we are using Mongoose OS on these devices, and as you might or might not know, every code, or if you want to write code for these devices, you have to write it in C. I think there are other options, but we're using C. And they are only publishing MQTT topics, like you can see in this very little snippet of code. I hope you can read it. If not, it's not that important. But they're only sending the distance in millimeters. This is more or less everything that they are sending. So via this Wi-Fi router, they are relying that to a public MQTT cloud service. Do you know what MQTT is? Anyone? MQTT? There are 2, 3, okay. It's a rather small protocol which allows you to send and receive and broker data, very small pieces of data, very quickly, and it can take care of offline scenarios. So if someone's not connected anymore, it can wait for something, or it can hold data. MQTT can hold data back, and until some consumer is online again, it will relay all the data. It can also skip data, whatever. So MQTT is quite a nice protocol for transferring little parts of data on large scale. So this cloud MQTT provider is then sending, or no, it's not sending, but we have an IoT gateway written in Go, actually, which consumes the data that is relayed by this MQTT protocol. And then this is how this kind of event looks like. This is what we make out of these sensor events. And now this is the point where an API has to get into the game. And we decided for API platform. Since you're here in my nice talk, who of you ever heard about API platform? There are some hands going up. I like this. Okay. Did you ever use API platform in production? Yeah, some of you. Okay, very nice. Well, I'll tell some basics. So this is what you get out of the box with API platform. As a developer, I am pretty amazed that they come with a complete, runnable Docker and Docker Compose developer environment. You just download it, you say Docker Compose up, everything is running. at least on my machine. The API, unfortunately, only comes with one demo entity, which is called greeting, and can do nothing else than say a name. They come with a so-called JSON-LD and Hydra abstraction layer serializer. This is where I will go into deep some minutes afterwards. It's an amazing protocol, an amazing format to describe API data. If you want and if you like it, I don't know if you do Spryker or something, they also come with JSON API support, if you need this. They generate all the Swagger for you. All the OpenAI specifications are generated by API platform on its own. So if you need to build a client, you can just use this one. They come with completely automatically generated documentation, which is rather obvious for an API platform, I would say. They come with an auto-generated administration interface, which is beyond amazing. They come with scaffolding tools to scaffold your PWAs, which means if you want to build a visual client, you just press a button and everything is just generated, and now you go on and continue writing Vue or React code. This is rather new, come with Merkle support for real-time on HTTP-compatible push mechanisms, which I will demonstrate. They come with Varnish support, which I never tested, but which seems very amazing. And they already come with Helm charts for Kubernetes deployment. So if you're into Kubernetes, you only have to fill in the templates, and then you get your Kubernetes descriptors. But at the very basic, what API platform is doing is they are reusing your entity descriptions if you're into doctrine. Can you read this? Someone cannot read that in the back, maybe? I hope you can. It's okay. Okay, so the only code that I wrote on this product stream entity are the little yellow ones. I got an annotation which is called API resource at the very top, one that is called API filter, and one that's called groups, which is actually a Symfony annotation for the Symfony serializer. And this API resource denotes this product stream entity as an entity that my API is exposing. That's it. There's even access control in it. I say, okay, API resource, product streams may only be consumed by users and not by anonymous or something. Now, this is the result. If you have lots of entities, you annotate them, you can restrict some operations or methods, then this is the result. I can show you live in my browser. If I find my cursor, here it is. Oh, I forgot to authenticate. Okay, wait a second. So this is now running on my local machine in a Docker container. And here we got the product streams. And since I'm currently not authorized, this should return you're not authorized. There we go. And they're great. Let's authorize. Now we should see that there is a 200. And now this is, you won't be able to read this. This is where I'm scaling up now. These are all the product streams that our shelf is tracking, okay? So Bex is tracked, it has a product, the product has offers, there's even a price on it, a box of Bex costs $50.90, and so on and so on. There's even the dimensions. So this is generated by API platform just by annotating entities or classes actually with this API resource annotation. Brilliant. If you're more into redoc, it looks like this. It's also completely auto-generated. You can just click at the bottom and then this documentation will just appear. So you might have seen this already on the documentation. You get filtering for free. This is also one more annotation. You say, please make it able to filter product streams by their product titles. It's even working with nested entities. You get pagination for free. So if you ask for several pages, you can skip the pages. You can cursor through them. And yeah, this is what I wanted to demonstrate you, but I just demonstrated it. You can search for things just like that. The standard output format of API platform is actually JSON-LD, which looks like this, but I guess JSON is more, well, what people would expect. So this is the plain JSON description of everything. But then JSON-LD is a very important concept in in API platform. JSON-LD is giving you metadata on your entities. So it's called the link descriptors, I guess, link definitions. I don't know. And they're saying, well, what we returned here is a Hydra. It's actually a collection, and this collection contains this kinds of guys, and then this JSON is following, and then they will give you pointers to other entities like this. The organization is not resolved in the final entity; it's just denoted by /organization1. You can just follow this link and do an API call on that link, and you will get the organization for this product. This is what you might know from JSON API already. And the so-called Hydra abstraction layer is doing what also JSON API is doing. They're adding relations into your metadata. They tell you in the beginning of every result entity where you can find itself, or how we got here, how we came here, and how we can find other entities, like here. So if you have a product offer embedded in a product stream, you can follow this link to find the details about that product offer. Whoa. This is where the magic begins. If you got all this stuff, especially that Swagger JSON, don't know if you know that, but then you can auto-generate everything. The more documentation and the more metadata you have, the easier it is to build clients. For example, Swagger itself is offering you this tool, Swagger CodeGen, and it can generate a client for you in any language. I built one using PHP. Here it is. It looks rather simple. This Swagger Client API product API class there is nothing that I wrote. This has been generated out of the Swagger JSON that JSON API platform was generating for me. So let's call this one. Here we go. This is resolving to Fritz products. Hope you like them. If I search for Beck, like Beck's, I will find Beck's products. Nice. What I cannot demonstrate, because currently it's not working, there is a GitHub issue for it. You can scaffold complete applications. I already said that. They are generating view and drag code for you, and you can just go into it and start changing things until it looks like you want it to look. And they come with all the features, which means you can just click on entities, you will come to the next entity, and now you can change the front end. And what they also have, and this is beyond amazing from my point of view, they're also generating an administration interface, which is not something that they invented, but they're using React Admin. And this is what I would like to show you. Here it is. I think I have to relog in. Also running on my local machine. Here we go. The product streams. You can edit them. And then they're resolving the slots where this one's living in. Sometimes it's working, sometimes it's not. But usually everything is working. So I don't know if you noticed that, but I did not write any code to have this one here in place. Okay. Anyone GraphQL? Of course, they're also generating GraphQL and endpoints if you want so. Here it is. Hope you can read it. So now I'm querying for product streams. And you can, as you know, GraphQL, you can decide what you want to have as related entities. So currently I'm selecting products and the offers and the prices and only supplier IDs. And I'm searching for Bex already. Here's a variable called Bex, more or less. So execute. There we go. There's result. What do you want to look for? Let's say Cola. I think Fritz is writing it with a K. There we go. Now you find Fritz Cola. Just like that. The only thing you have to do to activate GraphQL in your API platform API is add one dependency. You don't even have to add annotations or something. It's just there. And if you want, you can restrict entities. You can say, this is please not exposed by a GraphQL. You can also restrict certain properties or something. I would like to talk a little bit about the not so obvious parts. For example, custom operations, data providers, authentication, testing, and server-sent events. I know that I don't have that much time, but I would like to show you the custom operations. If you want to create an endpoint, an API platform, which is not covered by an entity that you have written, you can just add an endpoint at this annotation level. I call it assigned product here, and where the path is. And then you write a so-called, no, it's actually not really a controller, but it's an action class. And then you can implement this action class. Just gets a request, you can do whatever you want. And the good thing is all the serialization, do you have a demo for it? Yeah, here it is. All the serialization of the entity that has been denoted by the ORM level, if you want to do it, is already auto-deserialized. So this one is annotated on a slot class, okay? And the action already gets a slot, which is deserialized by the context. That's it, so you can work on that slot. If this is not related to an entity, which is also perfectly possible, you can just get the request and do whatever you want. Custom data providers. So usually in an IoT context, you would not store sensor data in your PostgreSQL database, but unfortunately, this is exactly what we do. Because as it turned out, CrateDB and InfluxDB are not running on Heroku for some kind of reason. But API platform is also perfectly working with MongoDB. We just used PostgreSQL for data storage because we could do so. And this is how we implemented it, actually. There is so the inventory, the both interfaces at the top give you just two methods each, one get collection, one supports. And this get collection, it's totally up to you how you implement it. If you have an InfluxDB, if you have a Cassandra DB, if you have a Cockroach DB, whatever you name it, you can just use it and provide this data provider, or write one data provider which implements these interfaces, and then you can interact with the data the same way you did before in Doctrine. It's a little bit hard to do it that way, but in the end you can use whatever you want without being restricted to PostgreSQL or some relational database. This is how it looks like. I used that inventory change event, which is on the model level, it's not an entity, so it's not annotated with an ORM annotation. And then I have a derived entity, a derived class, which is called the inventory change event of the entity namespace. And this one now is an entity, and this is exactly what we're using. We have an abstract level of data provider, and this one's providing data. And then we have an implementation of it, which provides data by PostgreSQL. And we're actually using this very nice library of Kevin Douglas, doctrine JSON-ODM, which conflicts a little bit with the Symfony serializer. And just by denoting a property with JSON document, you can just put JSON in there. You can even query for it. This is how it looks like on database level, but I will just skip that. And this is how it finally looks like in the database. So this is now what we call the inventory change event, because it contains the sensor event at the top, and it also contains inventory changes in the bottom. Currently, at this event timestamp, we got 2 boxes of type product 51, whatever that is. We forgot to put the title in it. I guess it was Shakespeare. These were the interfaces. A small word about authentication. If you want to communicate with APIs, I would always prefer JOTs, because JOTs are, well, the way to go, and they are self-signed, so you can trust every JOT you get, and this is exactly what we're doing. When a request hits our platform, we are never querying the database and get the user. We only trust the JOT that's incoming, because we signed it when we issued it. And this is working amazingly simple in a Symfony context. It doesn't matter which Symfony application you're writing, you should use JOT authentication for everything that's API related. It's just amazing. This is how it looks like. I don't know if you know JOTs, I hope you know. Don't raise your hands if you don't know it, I don't know. But the only information that we're transporting is the username of the current user and its role. And if it's a role user, we can trust it because we signed it. I will skip the testing part to come to something much more interesting. Mercure protocol, real time. Have you ever been using Socket.io? Some of you. Do you like Socket.io? Is it simple? Connection, how is it called? Data stream or socket on connection, on data, on something, and then something is happening. It's not that simple to implement from my point of view. And this is why some people came up with this very nice Mercure protocol. This one allows you to send data from a server to your clients, which listen to it in a native way. You don't have to put any client library in your browser to consume these events, at least not in modern browsers. It doesn't work on Microsoft, but there are polyfills for it, fortunately. What API platform is giving you, it's adding auto-discovery features for Mercure-aware entities. And the only thing to enable it, as you might imagine, you only have to say API resource, Mercure true, that's it. And then what it's actually doing, it's just putting a link to your so-called Mercure hub in the headers of the response. And then your client knows that this entity can be updated on the server, and the server will send you updates via Mercure protocol dynamically. This is how it looks like on the client. This is browser native. I did not import anything to use this event source. You can do this in your Chrome browser without importing anything. You can just listen to servers for events if they are HTTP compatible. This is the only restriction. And since I know that you're now waiting for a demo, I'll show you. So this is how our frontend looks like. You see all the slots. This is water. And this is Apfelrote Beteschorle. And then we have the so-called product streams. They are tracking the real current stocks of products. For example, I hope you can read this. Biozisch Holunderblüte, very nice product. And I guess Bex is now tracked by the sensor Adolfo1 on my local machine, which is more or less my name. So let's send something to that sensor. And keep it open simultaneously. It's really hard to see on my machine in dark mode, I'm sorry. Oh. Oh. So, let's say, I am measuring 1 meter. Did it move? No. Okay, let's measure 20 millimeters. Ah, it moved. You have to watch this fullness bar here, okay? Thank you. No, it was just amazing that it's so simple to implement because you only have to create the so-called Mercure hub, announce your change events, and tell the client, you can listen, I will tell you if something is happening, and it's just working. This, by the way, is a Vue application. Not that much magic. Okay, so takeaways. Too long, didn't listen. API platform builds APIs out of plain entity descriptions. You just describe a class, you can also call it an entity, and it will build APIs for you just by this declaration. It comes with filtering, pagination, and ordering built in. You can always modify something, you can write it on your own using these event sources on your own, but it comes with it. If you only have an entity-based application, domain model, everything is just working out of the box. It's compatible with all major standards, and this is really important. If you trust the stuff that these people are doing, you trust the people who are doing things right. At least this is my opinion, but trust me, I read lots about specifications and they are doing the right things. It can scaffold applications and clients for you, which is taking you away lots of work, and it even generates a GraphQL API for you, so if you want to go on your own, GraphQL is perfect for front-end development. It comes with container templates, so you're ready to deploy to production on Kubernetes. I never tried that on my own, I'm hosting on Heroku, but well, there was not too much to it. It currently also supports Mongo and Elasticsearch. So this is what I did not mention, but if you store data and you synchronize your index on Elasticsearch on your own, you can just add an Elasticsearch annotation on it, and it will search. If you want to filter for something, it will automatically search in Elasticsearch for your entities. And if you know Symfony rather well, the learning curve is extremely low. It's really simple to get started with it. And that was it from my side. Thank you. So someone told me that we now got 15 minutes for questions.
Yes.
This is your chance. You can really ask me anything. You can also ask me something about Turbine Kreuzberg. My Twitter handle is STADOLF, Stadolf. There's a question.
Yeah.
I know that guy.
Hello, yeah, working in the same company, but personal question, would you ever use, again, something else than API platform?
Oh, there are lots of options. So I evaluated Strong Loop on Node.js, which is quite capable, I would say, but it cannot do all the auto generation. And if you want to use GraphQL, I guess you have to cope with Apollo GraphQL server on your own a little bit. There is not much out there which has all the capabilities that I found in this platform, actually. There's something completely different. Now, you might have noticed that this is a monolith. Now you're writing a monolithic application. If you want to put another microservice behind your endpoint, you will have to route through it or something. This is not comfortable. This is why you might think about using an API gateway like Kong, or there are lots of others actually, and put microservice behind them. Problem, this won't work with API platform just like that. I mean, you can export the Swagger JSON, but now you have to take care of the routing on your own. This is why I would say API platform is really great to get you it's brilliant to get you started doing an API for a closed use case. If you already have lots of things, go with API gateway applications. Strong Loop is maybe an option. Also, in the Node.js world, there are lots of little frameworks which can do the routing for you, maybe the authentication, but they are not coming with all the entity relations. They don't come with all the sorting options out of the box and everything. So this is the real magic in API platform. Does that answer your question? Anyone else? Who of you is a Symfony developer? Do you like Symfony? Who of you is a Laravel developer? Berlin. No one. Okay, you have to go to Portugal. Everyone is doing Laravel. Who of you is currently developing an API? Some of you. Very good. And what do you use? Do you use it? Do you do it by hand? Yes. Would you consider using this kind of stuff? No. Why not? For bigger environment. Do you mean versioning like, versioning, like API versioning? Okay, you're changing your endpoints. There is versioning. You only have to change, what do you mean by versioning? You can just change the version number and then your client knows, no, I cannot consume this. There are no fallbacks, actually. You have to take care of fallbacks on your own, that's right.
And data structure as well. So you can, so the result of your data entities, for example, you can also do versioning here.
The data structure on your current version, like say API version 004, of course.
No, I mean, if you call an API, something comes back, right? This is JSON or whatever. And is this also version? So the data structure, what comes back? Because it's also very important. If you have a bigger company and with hundreds of teams and peoples, so
you would expect that there's maybe a version property in the return, I guess.
Yes.
Say this is an entity from version 1. This is, as far as I can remember, really not implemented, that's right. But it shouldn't be that hard to do it on your own because you can, of course, return the current API platform, or you can mix in the current API platform's version into this result document. But it's hard to give the fallbacks and say, well, now I responded with a 5. If you need a 4, you can use this link. This would be rather hard, I would say. And it's not, API platform cannot run 2 versions at the same time. This is also not possible, that's right.
Yes, that's the reason why I'm not using it.
Mm-hmm. And if you have Kubernetes, you can run both at the same time, yes. There's a question.
Maybe this versioning, just in my opinion, is not necessary. Maybe even an anti-pattern would show that under certain circumstances, your services are not very well designed because you can have some alternative checks like contract tests and so on, and I think you can apply it here too. I think this could be possible. Yes.
I mean, you're so right. If you do it on a large company, you will be really, you will get really problems if you roll out something and lots of people rely on you and you don't have this fallback. And don't tell them which version.
Maybe we can discuss this again because I think we do this with lots of people. But yeah, can I ask another question? It's maybe not so into this API direction.
I don't see any hands, so but sure.
Okay. Did you consider experimenting with other sensors besides these distances, like
Our first take was to use weight, like there are little sensors which you can bend, and depending on the amount of bend, it will say, oh, this weighs 10 kilograms, and we put them in the front of the shelf, and every time we dragged out a crate, everything just fell off, and this is why it did not work for us. If you have other scenarios, like in medical, pharmaceutical applications, they have weight sensors. They're very small ones where you put something on it. For this use case, for this beverage use case, you put lots of crates in one large shelf. We think that is maybe the best way would even to use image recognition and say, okay, this looks like there are still 3 of them. Because also the distance measurement is not that reliable. It works quite well for us, so 90% is always working, and sometimes someone is measuring 0 because it's looking right through all the bottles. So to the end of our wall, which measures nothing. This can happen. Yeah.
My question was a bit in a different direction, because when I heard about your shelf first time, I thought about those Amazon jobs where people go in, take something, go out, and maybe in your storage you have similar problems that people can't put things in the wrong shelf, or vice versa. You have problems like that, and I don't know. Still things like RFID come up my mind and stuff like that.
That's exactly, this is a different problem. We're currently just solving the problem of measure how much we have. But one of the major problems is figure out that no one did a mistake when putting something in there. And our delivery service is always putting them in the wrong slots. This is why we're currently putting little Aufkleber, little stickers at the front. So everyone knows where to put what, and sometimes it's working. There are other human engineering things that you can do, like putting colors on the slots, and Coke is always red and milk is always blue. And the very last step is actually to say, beep the sensor with your mobile phone, and it tells you this is Coke. This is exactly the thing. So of course we are printing QR codes at these slots, but no one can scan all the QR codes. This will take too long if you are putting things in the shelf. This is why NFC is one of the best solutions. That's right. It would be too expensive to put displays on all the slots. If you put one LCD display, which is saying Coke on each of these slots, this would be too expensive for a beverage use case. But if you think of a real large industry use case, that could even work, because one of these displays is around $5 or something. So you can do it. But we decided against it, actually. Good thing about these sensors is you can also put them at the roof and then measure it down. So if you have water going down, you can also measure this. This is also working. We tried that. But interesting, Turbine Kreuzberg is not that much interested in the IoT stuff. We do it because we have some colleagues taking care of it. We are more interested in what comes after, in the marketplace stuff. Like people have a demand. They say, I need lots of beverages. And there are some suppliers which can deliver. And then they can negotiate automatically who's delivering. This is what we find very interesting. Anyone else? From the back, maybe. If not, is my Twitter handle there somewhere? You should follow me. I could need more followers. You can also follow me on Instagram, but it's quite not that interesting. Besides that, I would like to mention that we are powering Coding Berlin here in Berlin. So if you want to go to a nice meetup group with me and lots of nice developers, last time we have been around 60 about next-gen commerce, it was headless commerce. You're invited. We're doing it every 2 months, every time a different topic. We're also doing this in Leipzig, Stuttgart, Düsseldorf, Portugal, all over the world. This is why we're currently founding an association called Coding Earth. This is who we are. And if you still have time, on May the 25th, we are also having our own little conference called the Dev Day 2019, happening here in Festsaal Kreuzberg. It's going to be amazing. Got 12 talks, very nice website that I built on Gatsby. And yeah, coding challenge, lots of sponsors, nice people. You're welcome. Thank you.